Okay, we revisit algebraic expressions in this section, but this time they're not direct translations of a statement. We've got to do a little bit of work to come up with the expression ourselves. So the good thing is that they kind of fall into a handful of formats. So let's go over some examples. So the first one is sodas cost 32 cents wholesale. How much would it cost for X sodas? Okay, so we're given it a unit price. This is what it costs for one thing. And we want to figure out how much it would cost for multiple things. So if you're ever not sure what to do, come up with a simple example that might help you figure it out. So you know that one can is 32 cents, two would be 64, three would be 96. What if I wanted to find 10 cans? What would I do that? I would do 10 times 0.32, right? So thinking of an example tells me what I need to do. I need to do 0.32 times x. So our expression is 0.32x. Okay, and it's going to be the same anytime they give you a unit price for something, and then how many you're going to buy, you just multiply them together. Okay, Paul wants to tip 18% on a bill of X dollars. He wants to tip 18%. So he's going to be taking 18% of X. It's actually a very similar one to the one above it, but instead of a price, he's doing a percentage. So remember, anytime you have a percentage, you need to change that to a decimal. So we always move the decimal place 2 times. That's going to give us 0.18. So we're going to do 18% of X. So that's going to be 0.18X. Okay, so 0.18x gives us the percentage. So that's going to be his tip. Okay, and then the last one, this is where we're dealing with different types of integers. So before we tackle this, let's just talk about integers for a second. I think we talked about this earlier on, but just in case. All right, so let's say that we've got, okay, so we've got these numbers. We don't exactly know what the number is, but let's say, well, let's go ahead and give it numbers. 3, 4, 5, 6, 7, 8. All right. Okay, so I have my starting point, and if I want to go to the next integer, that means I'm going to go up by 1. Okay, so going from 3 to 4, I'm going to go up by 1 to get to the next integer. Now, if I want to get to the next even or odd, the next even or odd, you're going to go from odd to even to odd to even. So you don't want to go up by 1. You have to go up by 2. Okay, so we're going to have to do plus 2 to get to the next even or odd. Oops, odd. Okay, so if you're trying to get to the next integer, you're just going to add 1. But if you want to get to the next even or odd integer, you're going to have to do 2. So if we're starting at an odd integer and we want to get to the next odd, we're going to have to add 2. Okay, if you look right here, if we start at an even, to get to the next even, we've got to add 2. Okay, so now let's go back to the problem at hand. It says an odd integer is x. What are the next 2 consecutive odd integers? Okay, so we have x. So the next odd integer would be x plus 2. And then the next odd integer after that, look at this, we're going to have to add 2 again. So we're going to add 2 and then add 2. So from the original one, we're going to be adding 4. Okay, so you can either think of it as adding 4 to the original one or doing x plus 2 plus 2. Either way, you're going to get x plus 4. Okay, and then if you're ever unsure, you can always kind of check it and make sure that it makes sense. So what if I started an odd integer? So let's just pick one, 11. Let's say we start at 11. Okay, the next one would be 11 plus 2 is 13. And then the next one would be 11 plus 4 is 15. Does that work? Are those consecutive odd integers, 11, 13, 15? Yes, those work. Okay, so when in doubt, use a simple example and see if it's making sense.